Audio Jungle.
Assalamualaikum warahmatullahi wabarakatuh. Hi guys, welcome to my YouTube channel. My name is Nazria.
Audio
Hasana.
Jungle.
I'm from grade 7. Today I will explain the material about
Audio Jungle. Audio Jungle. Audio Jungle.
Equilibrium condition. For a system in equilibrium, the chemical potential of each constituent must be the same everywhere in the system. If there are several phases present, the chemical potential of each substance must have the same value in every phases in which that substance by and we obtained dP equal minus S dt plus P dV, where S and V are the molar entropy and molar volume. Then d mu per dt P equal minus S and d mu per dV T equal V. The derivative in equation are slope of the curves mu versus T and versus V respectively.
Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
Stability of the phases of a pure substance.
Audio Jungle.
The third law of thermodynamics. The entropy of substance is always positive. This fact combined with so that d mu per dt is always negative. Consequently, the flow of mu versus T at constant pressure is a curve with a negative slope for the three phases of a single substance. We have d mu solid per dt P equal minus solid d mu liquid per dt equal minus S solid d mu gas per dt equal minus C gas.
Audio Jungle.
at any temperature as gas greater than as liquid greater solid.
Audio Jungle.
The entropy of the solid is small, so that in figure 12.1, the mu versus T curves for the solid curves as has a slight negative slope. The mu versus
Audio Jungle.
T curves for the liquid has a slope which is slightly more negative than that of the solid curves out.
Audio Jungle.
The entropy of the gas is very much larger than that of the liquid, so the slope of curve G has a large negative value. The curves have been drawn a straight line, the should be slightly convex downward. However, this refinement does not affect the argument. The thermodynamic conditions for equilibrium between phases at constant pressure are immediately referenced in figure 12.1. Solid and liquid coexist in equilibrium when mu solid equal mu liquid. That is, At the interaction point of course S and L, the corresponding temperature is Tm, the melting point. Similarly, liquid and gas coincide in equilibrium
Audio Jungle.
at the temperature Tb. The interaction point occurs L and G, at which
Audio
ρ liquid equal mu gas. The temperature exit is defined into three intervals. Below Tm, the solid has the lowest chemical potential. Between Tm and Tb, the liquid has the lowest chemical potential. Above Tb, the gas has the lowest chemical potential. The phases with the lowest value of the chemical potential is the stable phases. If liquid were present in a system at the temperature below Tm, figure 12 and 2, the chemical potential of the liquid shall have the value mu delta, while the solid has the value mu beta. Thus, liquid could freeze spontaneously at this temperature since freezing will decrease the Gibbs energy. At a temperature above Tm, the situation is the reverse. The mu of the solid is greater than that of the liquid, and the solid melt spontaneously to decrease the Gibbs energy of the system. At Tm, the chemical potential of solid and liquid are equal, so neither phases of reaper. They coexist in equilibrium. The situation is much the same near Tb. Just below Tb, liquid is stable, while just above Tb, the gas is the stable phase.
Diagram illustrates the familiar sequence of phases observed if a solid is heated under constant pressure at a low temperature. The system completely solid at defined temperature Tm. The liquid forms. The liquid is stable until the vaporized at a temperature Tb. The sequence of phases is sequence of the sequence of entropy value, and so is an immediately consequence of the fact that heat absorbed in the transformation from solid to liquid and from liquid to solid.
Pressure dependence of mu versus T curves. At this point, it is natural to ask what happens to the curves if the pressure is changed. This equation is answered using equation 12.2b in the form d mu equal v dv. If the pressure is decreased, dv is negative, v is positive, hence d mu is negative, and the chemical potential decreases in proportion to the volume of the phase. Since the molar volume of the liquid and solid are very small, the value of mu is decreased only slightly for the solid from A to E axon, for the liquid from B to B axon. Figure 12.3a. The volume of the gas is roughly 1000 times larger than the of the solid or liquid, so the mu of the gas decreases greatly from C to C axon. The curves at the lower pressure are shown as the same line parallel to the original lines in figure 12.3b. The figure has been drawn for the gas V liquid greater than V solid. Figure 12.3b shows that both equilibrium temperature but interaction point have shifted. The shift in the melting point is small, while the shift in the boiling point is relatively large. The melting point shift has been exaggerated for its emphasis. It is actually very small. The decrease in boiling point of a liquid with decrease in pressure is neatly illustrated. At the lower pressure, the large of stability of the liquid is noticeably decreased. If the pressure is reduced to a sufficiently low value, the boiling point of the liquid may even fall below the melting point of the solid, figure 12.4. The 3 is the temperature at which the liquid stage, the solid sublimes at the temperature T. The solid and vapor coexist in equilibrium. The temperature T beta is the sublimation temperature of the solid. It is very dependent on the temperature. Clearly, there is some pressure at which the 3 curves intersect at the same temperature. This temperature and pressure define the triple point. All 3 phases coexist in equilibrium at the triple point.
Sure dependence of mu versus T. Whether or not a particular material will sublime under reduced pressure rather than melt depends entirely on the individual property of the substance. Water, for example, sublimes at pressure below 611 Va. The higher the melting point and the smaller the difference between the melting point and boiling point at 1 atm pressure, the higher will be the below which sublimation absorbed the pressure in atm. Below which sublimation is absorbed can be estimated for substance obeying Thornton's rule by the formula in P equal minus 10.8 TB minus Tm per Tm. Ferron equation, it faces alpha and beta. Substance is mu alpha T, P equal mu beta T, P. D mu alpha per dt P dt plus D mu alpha per dp T dp equal D mu beta per dt P dt plus mu D mu beta per dp T dp. Mu alpha equal G alpha D G alpha per dt P equal minus S alpha D G beta per dp T dp equal V alpha minus S alpha equal dt plus P alpha dp equal minus beta S beta dt plus P beta dv. dp per dt equal S beta minus S alpha per P beta minus P alpha equal delta trans S per delta trans P. Delta trans G equal delta trans H minus T delta trans S equal 0 at equilibrium. Delta trans S equal delta trans H per T. P per dt equal delta trans H per delta trans P. Delta fusion H greater than 0. Delta vaporization H greater than 0. Delta sublimation H greater than 0 in always. Delta fusion P greater than 0
Audio
is
Jungle.
usually delta vaporization P greater than 0 and delta sublimation V greater than 0 is always T trans greater than 0 is always dP per dt greater than 0 always.
Thank you for your attention.
Audio
Don't forget to
Jungle.
like and subscribe my video. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.